Procedure for hypothesis testing. So here is a step-by-step guide to conducting a hypothesis test. So a researcher has a hypothesis test and the researcher wants to test it. So this is the procedure for testing hypothesis testing. 1, state the null and alternative hypothesis. So the null hypothesis, HO, a statement of no effect or no difference. Alternative hypothesis, H1, a statement that contradicts the null hypothesis. Step 2, choose a significant level, that is alpha. This is the probability of rejecting a true null hypothesis. Common values are 0.01, 0.05, and 0.10. So one of these can be used to be able to be the significance level in hypothesis testing. Step 3, determine the appropriate test statistic and its distribution. The choice of test statistic depends on the type of data, the research, and the research question. The choice of test statistic depends on the type of data and the research question. So common test statistics include the t-tests, which we have just explained, is for comparing means of 2 samples. Z-test for large samples or known population standard deviation. F-test for comparing variances of 2 samples. A chi-square test for categorical data. Step 4, calculate the test statistic. So under calculating the test statistic, you use the sample data to calculate the test statistic. Step number 5, find the critical value or p-value. So a critical value, this is a value that separates the rejection region from the non-rejection region. A p-value, the probability of obtaining a test statistic as extreme or more extreme than the observed one, assuming the null hypothesis is true. Step number 6, make a decision, that is, reject or fail to reject the null hypothesis. If the test statistic falls in the rejection region or the p-value is less than the significant level, reject the null hypothesis. Otherwise, fail to reject the null hypothesis. Then step 7, interpret the results. If you reject the null hypothesis, there is evidence to support the alternative hypothesis. If you fail to reject the null hypothesis, there is not enough evidence to support the alternative hypothesis. So the researcher will argue and interpret the results based on how the null hypothesis either has been supported or you fail to reject the null hypothesis. So this is the procedure for testing hypothesis testing. Now we can look at an example. So what is an example of a procedure for hypothesis testing? Suppose this is the researcher. Suppose a researcher wants to test if a new fertilizer increases crop yield. As a country in the previous years in Kenya, Kenya has faced some scenarios where there has been hunger and food shortage. So someone may come out and argue, if you introduced a new or a different fertilizer, it may increase crop yield. The crops could be beans, the crops could be maize, the crops could be maybe they could be cash crops, or they could be other types of crops that the researcher or particular farmers are interested in. So suppose you want to test if a new fertilizer increases crop yield. So number one, under step one, now the null hypothesis might take the following pattern. The new fertilizer has no effect on crop yield, and the alternative hypothesis may read the new fertilizer increases crop yield. As we can see from here, the null hypothesis is negative. It is talking about no effect on crop yield. The alternative hypothesis is putting forward a case that is positive, that there is new fertilizer, or the new fertilizer increases crop yield. So you can see it is opposite. So null, the new fertilizer has no effect on crop yield. Alternative hypothesis H1 or HA, the new fertilizer increases crop yield. So at that point, the researcher under step one has stated the null hypothesis and the alternative hypothesis. At number two, the level that will be used for significance here is chosen as 0.05. Then step three, the test statistic. In this case, the test statistics is assuming the data is normally distributed. So you want to look at now, once you introduce the new fertilizer, if it is, for example, maize, how many bags have been harvested on 1 acre after using the new fertilizer? So you could say maybe 30 bags or 40 bags. So previously, when you have been farming, you are using a different fertilizer. So you might have now done another acre with the old fertilizer. So you have now two sets. You have one acre where you have used new fertilizer. You have 1 acre where you have used old fertilizer. So you also find out when you use where you used the old fertilizer, how many bags did you get? Maybe the bags could be 10, other things remaining the same. So here you have received 10 bags per acre. Here you have received, say, 30 bags per acre. Then you'll move now to step 4, which is you calculate the T statistic using the sample data. So the sample data of 1 acre, you use that data to calculate the T statistic using sample data that has been obtained. Then under step 5, find critical value or p-value using a T distribution table or statistic software. So you could use, for example, SPSS, a particular version. Then you put that information there. You see, for example, what is the spread in relation to that particular data that you have used. Then step 6, you make a decision. So the researcher makes a decision. If the calculated T statistic is greater than the critical value, or the p-value is less than 0.05, which we had selected in step 2, reject the null hypothesis. So if, for instance, you have found that the new fertilizer has been used and the yield is higher, then at that point, when it comes to the decision, then the null hypothesis would be rejected. Then number 7, an interpretation has to be done. If you reject the null hypothesis, which was no effect, the new fertilizer has no effect on crop yield. So if that is rejected, then there is evidence to support the claim that new fertilizer increases crop yield, right? So in that case, we accept the alternative hypothesis that new fertilizer increases crop yield. Then the researcher goes ahead in terms of that interpretation to give maybe corroboration with previous research that has been conducted, whether this is consistent with previous research or what the researcher proposes.